So now it's time to take our design to the next level. We began with simple IPO charts, and then we moved into flowcharting, and we were flowcharting basic sequences, top to bottom code. And that's fine, but our coding knowledge has expanded quite a bit since then. So let's do a quick review of everything that we know up to this point. So what are these symbols? So on the left-hand side, these are the 4 symbols we learned during the last design session. So the first one is our terminal symbol, which basically represents our start and end of every single flowchart that we do. Following that, we have the parallelogram, which is an input-output symbol for reading and displaying data. And then next up, we have our processing, our rectangle, our processing shape, which we use for all forms of processing. So some of those might be setting a value, calculating a value, incrementing a value, rounding a value, or anything in between. And then finally, we learned the connector symbol. And this is for when our top-down structure, our structure that got so long that it basically wouldn't fit on the page or start to get unreadable. So what we do is we use this as kind of like a teleport. And it's a labeled connector that we have a copy of somewhere else. And when we get to this point in the flow jumps over to where the other point is with the same label, and we continue on with the rest of the program. And this is just for simplicity in terms of being able to read and write the code, or read and write the design. So in order to make these things work, we have to be able to connect them together. So we use directed arrows. So we always follow the arrowhead. Whichever direction it's going, that's the flow of the program. Now there's a few rules. They always need to be horizontal or vertical arrows. No diagonals, no crisscrosses or anything like that. Reorganize where your symbols are so that doesn't actually come to be. So obviously 3 different sets. We have straight lines, we have elbows, and then we have joining lines. Okay. You'll notice that in the joining ones, only one arrowhead exists there because one comes from something else and kind of falls right into that. So last time we learned about the sequence structure. Today we're going to learn about 2 things, technically 3 things really. We're going to learn about decisions, which means making a true-false type, true-false type decision. We're learning about cases, which is just multi-selection, and we're also going to learn about something called a module, which is how we symbolize subprograms or methods inside of our design. So this is what our basic sequence structure looked like. It had a start and it had an end, and then there was some form of happenings or actions going on in between. So in this case, there was some form of input-output operation, and then there was some processing, and then the program ended. A very straightforward structure, literally straightforward. So let's get into the nitty-gritty of what we're talking about today. Decision structure. So this is our if statements. We want to make 1 or 2 choices. So it's either going to be the most basic structure that we know, which is a true-false question. And then you either go on the true path or you stay on the standard path. So the standard path would just keep flowing down, so top to bottom. So it didn't pass the true check. If it did, though, then it's going to veer off and go do something else, some form of sequence of code. Now, I say sequence because it could be a complete sequence like we had on the previous slide here. It could be a series of inputs, outputs, it could be some processing, or it could even be another decision. So that's another thing. So you can actually have these decisions feeding into decisions. And that's the same thing as having an if statement inside of an if statement. There's nothing wrong with that at all. So once it's done that sequence, it comes back and rejoins with the flow. So we can see how the arrows direct and they flow down with the rest of the program. And then it continues on. Now what about when we have 2 choices? Well, in this case, there is no standard path. It has to choose one or the other. So in this case, it's either going to go to the false case, which who knows what that's going to do. It's going to do some form of sequencing, or it's going to go in the true case, which is going to do a different set of sequencing. But in either case, whenever that sequence is done, it all leads back to the standard code path, which is going to continue on with the rest of the program. So this is what your design is going to look like. Again, those sequences can be any form of symbols that we use in our flowcharts, such as more decisions, processing, read and write operations, our parallelograms, things like that. Anything there. So let's take a look at an example. So design structure example, find the difference. Now we all know when you want to find the difference between two numbers, you just subtract them. But it always brings up that problem of what if one number is bigger than the other one and we don't know which one is the bigger one? So we might end up with a negative result. Well, Let's make an if structure. Let's make a decision structure that handles that. So is x less than, or is x greater than y? So this is our true-false check. It's either true or it's false. If it's true, then we're going to calculate the difference as x minus y, because we want the bigger number subtracting the smaller number. Now you'll notice on the right-hand side here, I've written the code, how we would interpret the decision structure as the code. If x greater than y, difference equal x minus y. Okay. But what if it's false? Oh, sorry. I guess yes. If it's on that side, it's going to continue on and continue down with the rest of the program. But what if it failed? What if y is the bigger one? Well, in that case, we're going to have a different set of process. So we have the else case in our code here on the right. And what happens in that else case? Well, it's the opposite operation. Difference is y minus x. And then either way, it's going to come down and flow with the rest of the program. So the decision is going to go one way or the other. Now, in this case, the sequence was only a single operation, which was a different calculation, an x or a y. All right. So far, so good. But what if we have those multi-selection things? So now we're into a case structure. So this is when we have one of several different actions are going to be taken based on some kind of comparison variable. Now, this isn't always a switch statement, and it isn't always an if-else if statement. It's got to be up to you to decide based on your needs. So a switch statement means that you're only checking for equality. Remember that. If you need to check for anything other than equality, when you go to code this design structure, you need to use an if-else if statement. You can't use a switch statement. So what does it look like? It comes down and we have this case statement, just like a switch case. So we have this case statement of some kind of variable. It means we're going to compare this variable against something. Well, what are we going to compare it against? Well, a number of different options. So here we split off into 4 options: comparison A, comparison B, comparison C, and comparison D. And each one has its own sequencing that's going on. Now, your case statement may be 2, 3, 4, 57 options. It doesn't really matter. You just make this nice long horizontal line and drop down an arrow for every possibility. Now, where you see that red, comparison A, comparison B, C, and D, that is where you're actually going to write the comparison operation, the comparison that you're going to be doing. And then we flow down into a sequence. And again, that could be just as simple as one simple processing command or an output command, or it could be a whole sequence of operations. It could even go into another multi-selection case statement. So whenever they're done, they're all going to link back up into a single arrow and then continue on with the rest of the program. So you can see how clean this actually looks. That's why I ask you to use tools to build these designs, either using draw.io or using, if you're going to be using pen and paper, then you should be using a ruler. Keep your arrows nice and neat, because you can see how messy this can get in a pretty big hurry. So let's take a look at an example, shall we? So this one is all about calculating somebody's Christmas bonus. Now, this happens in a lot of companies in North America or various places around the world that celebrate Christmas. So the idea is, depending on how many years you've worked at a company, you've earned more Christmas bonus pay. And it's just a perk for being a long-time employee and showing your loyalty. It's fairly common. So the structure below indicates actions to perform depending on the value in years employed. Years employed is our variable that we're going to be comparing against. So we're saying case years employed. Now we got to look at all the different ways we're going to compare that. Now we can compare it against one specific value like 0, or a range of values from 1 to 5, 5 to 10, or anything else. And you notice in each one of these, they did a different mathematical operation. Set bonus to 0. So if it's your first year working there, you don't get a Christmas bonus. Sorry. If you've been working there between 1 and 5 years, you get $200. That's nice. If you've been working there between 6 and 10 years, you get $400. If you've been working there anything outside of that, so that means 11 or greater, then you get $1,000. But either way, when they're all said and done, whichever option it went into, they all link back up and carry on with the rest of the program. So we got to look at the 4 different comparisons here and how we would write that in code. What does that actually mean? Well, the first one, for example, is saying if years employed is exactly 0, then set bonus to 0. The next one is saying if years employed is between 1 and 5, then set, that should be, I think I forgot to set all my bonuses. Yes, that's my fault. Then you're going to set that bonus to 200. And the next one is going to be 400. And then the final one is going to be 1,000. Let me just go back in here. Let's get back to where we were. So with that 0, 200, 400, and then the last case is simply, that's the same as your else. Your else case in this case is going to set it to $1,000. So other, when we see it in a design case statement, just means else. If you're using a switch statement, then it would be default. Now this, you got to look at this and say, well, I have to code this as an if-else statement. I can't use a switch statement because we're looking at ranges of data. We're looking at less thans, greater thans. You can't do that with switch statements. You can only check equality. If I had all specific values, let's say 0, 1, 2, and 3, then I could actually use a switch statement because it would be only when it's 0, only when it's 1, only when it's 2, and only when it's 3. So that is our most complex structure that we're probably going to work with when we're talking about our flowcharts. But there's another symbol that we're going to learn today, and that's how we deal with subprograms or modules. So, module symbol, subprograms. So a procedure or a program module such as a procedure or function, it's represented by a special symbol that kind of looks like a Canadian flag. So that's what students have commonly called it for years now that I've been teaching this course, the Canadian flag. But either way, this is what it looks like. It's a rectangle with 2 lines on the side to separate it from a processing. Okay, now how does this actually work? Well, when you use it, you have to specify certain information so it's clear what you're doing. What that means is you need to indicate the name of the subprogram, any parameters, and any return values, if any. So here you say calc_rec area with length and width, store area. So what that tells me in code, I would call that by saying area equals calc_rec area bracket length comma width. Great. Now sometimes you're just creating a procedure, so you wouldn't need that store line because you're not storing a result. Sometimes you don't need any parameters, so you wouldn't need that width line, so you would just ignore that one. So you only put the things you need in there. You're always going to need the call line. You may need the parameter line. You may need the store line. It depends on yours. Now, some of you are probably thinking, oh sweet, I can just throw one of these in the middle of my flowchart and walk away. Mr. Lane doesn't know what's going on in there. Mr. Finley doesn't either. So what do we do? Well, you don't get away that easy. Whenever you use one of these symbols in your code or in your design, you need to supply a second flowchart. A flowchart that does the logic of that module and only that module. How do you designate these flowcharts or separate them? Well, the way you do it is instead of writing start in the start terminal, you write the name of the subprogram, calc_rec area, for example, instead of start. So that's the last new module. Now let's do a quick review and make sure that we know all the symbols that we've learned today and in the past. So pause the video for a second and see if you can remember the names of all of these symbols. I'll wait. Okay, hopefully you're back. Now, on the left-hand side, starting at the top left, we see our terminal symbol. Right below that, we have our input and output symbol. Below that, we have our processing symbol. On the far right, on the top, we have our connector, followed by our decision, and then finally, our module. So these are all the symbols we're going to be learning for our entire design unit, all of our flowcharting. We are still going to have to deal with some new mechanisms when we talk about flowcharting later on. One more piece to the puzzle. But it's not going to introduce any new symbols. It's just going to introduce us using arrows in a different way. So we can kind of reroute the flow of the program. Kind of like we do with our decisions and our if statements, but for other purposes. So that's it for Design 3.0.